Hello, and welcome to today's web seminar, Navigating the Road to Success in the Internet of Things, sponsored by Infostretch and featuring speakers Sunil Pillai, Director of Infostretch Labs, and Brian Salisbury, Vice President of Product Management at Comtech Telecommunications. I'm your host and moderator, Beth Romanek. Thanks for joining us today. Before I hand it off to the speakers, I'll explain the controls on this console. The three panels on your screen can be moved around and resized. At the bottom of your console, you'll also see a widget toolbar. Through the Additional Resources widget on the right, you can download a PDF of today's slides. If you experience any technical issues, please send us a note through the question field beneath the panels, and we'll be on hand to help. Our responses can be read in the Q&A panel to the left. This is also how you submit questions. There will be a Q&A session at the end, so feel free to ask questions throughout the presentation. And finally, to optimize your bandwidth for the best viewing experience, please close any unnecessary applications. This event is being recorded and will be made available to watch on demand. Once the recording is ready, you'll get an email with instructions about how to access the presentation. And with that, I'd now like to hand it over to Josh Galdi, Director of Marketing at Infostretch, for a brief introduction.
Great, thanks, Beth, and welcome, everyone. Let me first begin by just introducing Sunil and Brian, your two presenters today. Sunil is Director of Infostretch Labs here at Infostretch, as Beth mentioned. He is an experienced engineering leader for mobile and enterprise applications. He has built and managed offshore and on-site engineering teams, managed mobile projects for Fortune 500 clients, and has deep technical and functional expertise in mobile and enterprise applications. Brian is the Vice President of Product Management for Comtech, as Beth mentioned, and a leading provider of mission-critical wireless communication solutions. He is responsible for a range of location-based service applications and the associated technology platform, which is used by mobile network operators, handset manufacturers, and automotive companies. He has more than 30 years of experience in the wireless industry with emphasis on mobile data and location-based services. He has worked in many parts of the ecosystem, from semiconductor and device manufacturers to software solutions and mobile network operators. Having lived and worked in Silicon Valley since 1993, Brian has been actively involved in the evolution of connected solutions leading up to the present Internet of Things. He holds a Bachelor's of Applied Science degree in Electrical Engineering from the University of Waterloo in Ontario, Canada. I now would like to pass it over to Sunil, who will take it from here.
Thank you, Josh. Good morning or good afternoon, everyone, depending on where you're dialing in from today. So IoT is a term that is used almost every day in some context, and hence there's a lot of interest but also a lot of confusion around it. So today what we wanted to do was throw some light on some of the nuances of an IoT ecosystem and what does testing and development for IoT really entail. We'll cover some of the fundamental concepts. We'll begin with that, and we'll deep dive into some of the development and testing challenges for IoT and how to kind of overcome those. And we'll also cover a very important use case for IoT, which is around connected cars. So move on to the next one. So we'll start before we begin. I think let's kind of look at. As I mentioned, because IoT has a lot of intrigue, what we are curious to know is the level of adoption of our participants for an IoT initiative they might have already embarked on, right? So are they right at the beginning of an initiative, or they're much ahead in the game? So if you could please put in your responses, and I think the results will come up in a few seconds here. All right, I think forward. See what it looks like. So that's very very interesting, and I think it's this webinar would be perfectly addressing the needs. So there are at least more than half of them are either exploring use cases or they have just started an ongoing development around IoT, and the group with no IoT initiatives. I'm pretty sure that in this webinar we'll cover some of the important aspects which will help you kind of take some decisions around IoT going forward. So let's get started with some of the initial fundamentals of IoT, the IoT landscape in general, and a quick primer around that. So if you look at where we are and where we're going to be in a few years from now, today IoT landscape is going through a very interesting inflection point. Essentially, there are need from enterprises to increase efficiency and build interconnected systems. But at the same time, the skills for it are in shortage because we have new paradigms and new technologies to kind of build upon, and they're a little different from traditional software. Enterprises, as you see on the left-hand side, are sitting on a lot of data that they're getting from the existing systems and existing sensors which might be out there. But really, there is no clear standard to kind of leverage the data in a meaningful and a very uniform way. There are a lot of big data products out there which are used for analytics, but each of them has its own idiosyncrasies which enterprises have to learn and then kind of adopt to. And we have a lot of IoT platforms in the market. And if you look at the cost of sensors, they've fallen dramatically. So one of the statistics, says that the cost of sensor in 2000, the average cost of a sensor in 2004 was about $1.30. Today it is at 65 cents, and 2020 it's going to be about 38 cents. So the lowering cost of sensors definitely has led to higher adoption, but the vendor landscape to manage all that is still complex. Now let's fast forward a few years from now, to 2020. Now, IoT systems and ecosystems are going to allow enterprises to really leverage the data for real-time decisions and also optimizations in a very meaningful manner. Digital business transformation efforts, which exist today, a lot of them are either driven by, earlier they were driven from the movement to web, and then they were driven by the movement to the mobile-first strategy. And going forward, you'll see IoT has been the main drivers of some of these digital transformation efforts. There's going to be about tens of billions of devices in use. Now that's a billion with a B. Now what that means is that you not only have a lot of data coming in, but you're also talking about extreme connectedness between all these devices. And hence the expectations around contextual relevant data are going to be much higher than they're going to be today. So what that implies, going forward, is that the business processes that are critical for enterprises and also the features that are prioritized by vendors for IoT products, they'll definitely have IoT inherently baked in as a core philosophy of how these services or these products should really behave. And this will have a far-reaching implications. Now, if you look at the next slide, this kind of shows you what the untapped potential is. Right? So in IoT, we have a lot of things today which are just waiting to come online, right, and be part of the ecosystem. You look at there are some numbers which is 300 million utility meters today, and they're not yet connected. So once they come online and they connected to the larger ecosystem, just imagine the kind of data and the kind of interaction that they would expect, and they would kind of contribute to the entire IoT ecosystem. We talk about IoT in agriculture, and there's a lot of progress on that front. But there are probably, you just take one aspect, there's probably 1 million vineyard acres which are still waiting to be connected to the entire ecosystem. We have connected cars and we have autonomous cars which are slowly getting mainstream traction. But there are about 150 million unconnected cars which are still waiting to come online. So when they do come online, what the implications of all this is that when they do come online, we will need to make sure that they can really coexist with other things in the system, and more importantly, really leverage the benefits of technologies like location, etc., which Brian will talk about in a few slides later, because they need the right context to really behave in the right ecosystem in the right manner. And some of these basic technologies that are building blocks like location, context, etc., are going to be really crucial for a very good, strong, functioning IoT system. So in the IoT landscape, really, then it's all about connectivity. So obviously, the key differentiator than what exists today is about connectivity. And when we add context to it, like location, it becomes really powerful and really meaningful, and that is when the real power of an IoT system ecosystem can really be leveraged. And then let's kind of, in the next couple of slides, let's kind of look at what does that look like? What does the IoT landscape look like in terms of connectivity, and then what are the nuances around it? So if you look at this slide, really you get a sense that it's not just connectivity, it's extreme connectivity, right? So you have different protocols, and we have two different sections shown here. There is one which is the consumer side of IoT, and the other one which is the enterprise side of IoT, which is more IIoT. So you can see that there are broadcast connections, there are point-to-point connections, MQTT and CoAPS are still the most widely used protocols for communication. Great network connectivity. If you look at the entire ecosystem, you need to have great resilient network connectivity, because a lot of the interactions that happen in IoT really are transferring data and then making sense of it. You need cloud analytics in a big way, because what do you do with this data is not only important in terms of providing the right analytics, but also providing the right prescriptive recommendations around it, so that you can actually fix and self-heal a lot of the systems which are in play. The cloud analytics is really a big component of IoT itself. And lastly, and last but not the least, really, if you look at it, these systems are really not monolithic, right? They are really a composition of a lot of different microservices which kind of come together, each providing its own niche as part of the system. And that also means that there is a lot of integrations with other players and other partners in the system, right? So this is really what one aspect of how an IoT landscape kind of looks like. And given that kind of a background, I think it's important to then talk about what are the nuances and complexities really of IoT testing. Now, if you I think this slide kind of covers the very most important aspects of any testing that is done for an IoT product or a service. One of the important things that you would see right in the middle is the idea of hardware and software convergence. So in IoT, a lot of the interactions that happens are at the confluence of hardware and software, and that data kind of gets put in a certain context and then gets processed. So what that means is that in kind of any kind of IoT testing that we do, the interaction between these two layers with firmware and with hardware needs to be tested at a point where any data that gets thrown out is validated for the right context and also for the right value. There's a huge volume of data. IoT data usually are shorter payloads, but they are huge bursts of data. And the testing for volumes of data which are intermittent, which may not be really uniform in nature, and how do you kind of test for those scenarios is very important, and that is different than how would you test typically an e-commerce system, which typically is either a read-heavy or it's a write-heavy kind of a system. They are very distributed in nature. So IoT by definition really means interconnectedness between many devices who actually come together. And so the testing strategies for helping with IoT really needs to have that support for really testing multiple systems which are moving in tandem and addressing the dynamic nature of the entire ecosystem. The devices themselves have very low footprint. They have very low capacity. So what that means is that any agents that you would typically install on a mobile application, for example, to actually test mobile applications, as a strategy may not always work with IoT because the amount of memory footprints you really have to consume is pretty limited. And so you have to devise strategies to circumvent that. Then, of course, the automation challenges around it, right? So typical automation strategies which allow you to kind of work with an endpoint and drive it all the way through now has to be scaled out so that you can really have automation across multiple endpoints which are moving in synchrony, and then you need to kind of get data points from all of them to kind of really decide what the automation results look like. So what kind of testing really helps with this kind of IoT, with IoT challenges? So really you have four different kinds. You can either have component validation, we can have functional validation, performance, or security validation. So around component, really it's around hardware, it's around sensor validation, it's around the embedded software. And when we talk about functional validation, they're really around device interactions. They could be around error handling. You really need to make sure you're doing valid calculations. You are kind of looking at your event registers and making sure they are kind of recorded properly. And performance, because of the volume of data, performance is so key. So synchronization, for example, interrupt testing. How do you handle multiple requests? And what is the consistency of data that really moves back and forth? And these have to be tested within performance. And last but not the least, again, is security and data, right? So with IoT and with the whole distributed system, security becomes of paramount importance. So how do you make sure that security is kind of baked in, not only from an access perspective, but also from the integrity of data that moves between different pieces of an IoT system? What are the encryption strategies and how do you test around it? What are the user roles and permissions? So these are the different nuances of testing that exist for supporting an IoT landscape. And if you move on to the next slide. So if you look at the landscape and the kind of testing that we would need, I think the important question is that, okay, so where do the bugs really exist, and and what kind of testing strategies really help for different kinds of bugs. So really, if you look at IoT as a landscape in terms of layers, if you move from left to right, you're really moving from the device, and to the right, you're really moving all the way to the very end, which is around the cloud or the mobile application. Starting with the device, really you start with sensors. So the bugs, obviously, sensors could be anything. It could be like a position sensor. You're talking about pressure sensor, light sensors, etc. And really the bugs in case of sensors could be around accuracy. It could be around sensitivity, around resolution. So it's important to make sure that we are looking and detecting those kind of data points when you're testing at the sensor side of it. Around sensors, power consumption is also very important because these are very small devices with low power capacities. So if they may work great, but if they're consuming a lot of power, they're not going to work for too long, right? So you have to test for those aspects which are very specific to sensors, which may not apply to other applications. As you move to the right, then you get into the controlling layers. Controlling layers mostly the SoCs, and you have onboard mechanics and onboard electronics which needs to be tested. Because your sensor could be working great, but when you put it on a board, you may realize that there are data integrity issues which are introduced, which may not really be a sensor issue, but may actually could be a simple thing like a voltage, which is not the right value for a controlling layer, right? So how do you test around these aspects? And those are the kind of bugs you'd find at the controlling layer. Then comes a very important layer, which is the communication layer. And as I showed you in one of the previous slides, IoT is all about extreme connectedness. So any testing strategy which does not cover communication is not going to be comprehensive enough to really test the entire IoT strategy. So we need to make sure that we are testing not only on the hardware interface side, but you're also testing more on the communication side, on the software side too. And when we talk about IoT communication, really there are two key things, among other things, which have to be really taken care of, is bandwidth and latency. So it is important to, and of course range. So it is important to make sure that we are looking for bugs which are related to bandwidth, latency, and range, and because these are the different aspects in the communication layer which can really render your IoT ecosystem not functioning to its optimum in a very quick manner. And it is at this layer that the issues around security also get introduced in a very meaningful way. So security testing really needs to happen very strongly at the communication layer. As you move further right, then you get into the session layer. So session layer really is where a lot of these messaging protocols come into play. You could have MQTT, you could have co-apps, etc. Now the bugs that get introduced here are going to be around protocol mismatches, for example. You have signature issues, you have backward compatibility issues, and then of course you have sync and async issues. So the kind of bugs you do here are more where the system seems to be working fine, but then you really see that over a period of time your system kind of deteriorates in performance, and those are the kind of bugs you typically find in the session layer. And interoperability, is very important because it is at this layer also that you're really integrating with different partners in the ecosystem. So the kind of data you can consume as a consumer, the kind of data you can provide as a provider have to be in sync with what is expected or what you expect from the system. And finally, we have the solution layer, which is really the cloud. And of course, you have analytics here and a lot of the big data insights that come into play here. So, we have to basically, the bugs are mostly around, have you designed for streaming data or have you designed for more offline processing? What are there bugs around storage? When you get a huge volume of data coming in, does your system really perform to its optimum? How real-time can your analytics really be? Or is it mostly, or are they really push-forward related bugs here? Right? And then finally, when you talk about mobile apps, the mobile apps, in case of an IoT, not only have the typical issues of bugs related to a mobile app in any scenario, but then there are also specific issues around, what kind of an offline strategy does it have? And when it comes into an IoT ecosystem and when it goes off, is it able to elegantly come on the system and kind of, and bow out of the system? And does it have the right communication protocols built in for communication, etc.? So these are typically the kind of bugs you would find in an IoT system, and the kind of testing that you would really need to do for kind of supporting that would be you either need some kind of a test bed so that you really set up test harnesses which really test out a particular area of this IoT system. For example, you could have beacons built in, so you really need a test harness for testing beacons specifically, so you address the real issues around that particular communication. You may also have the need of a test lab. So test lab essentially is where you have entire set of harnesses and services built in, where not only are your actual code testing being done, but also the right methodologies of testing are being followed, so that you have the different layers covered in the right form and the right priority, right? You may need certification programs to be built in, so that not only is your system functioning and you have no major blocker bugs in your system, but also they are certified to optimally perform as per the existing industry standards. So these are the different testing that should be kept in mind when we actually kind of get into testing for these scenarios. So having laid that kind of a groundwork for IoT and the nuances for testing and what kind of bugs could be found, at this point, I'd like to hand it over to Brian, who's going to talk about a very important use case for IoT, and which is around connected cars.
Thank you, Sunil. Yeah, we at Comtech, we definitely see the connected car as part of this bigger thing or bigger ecosystem that people refer to as the Internet of Things. And I think everyone you talk to has kind of a different perspective of what the Internet of Things really is, and it's probably going to continue to evolve over time. We think of the connected car as sort of being one of the bigger types of things that are in the IoT space, and there are many use cases and scenarios that may be pretty much just contained to the automotive segment, but there are also a lot of very interesting use cases emerging where the car is needing to communicate with other types of things that are part of the IoT to enable various things to happen, whether it be to improve the safety or the comfort of the driving experience, or if it is focused more on the operation and reliability of the vehicle, or if it's perhaps tied into capturing information that's used to help improve the ongoing planning and maintenance of road networks, etc. This slide here, the overview of connected cars, kind of gives a high-level summary of how diverse the elements that go into the connected car can be. As I said, sometimes things are kind of more focused on the people in the vehicle, and that's really where the infotainment and content aspect comes. Historically, people had an AM/FM radio, that evolved over the years with 8-track players and cassettes, and now today, people's expectation is that when they get into their car, they should be able to access the same type of information and entertainment content that they can get when they're at home or from their mobile device. And so this has definitely increased the importance of the car itself being connected to the internet, and it also brings with it the need to manage and present that information in a way in the vehicle that is safe. So, the type of interaction for the driver needs to be quite more controlled and constrained so that they can continue to focus on driving the vehicle, whereas for the passengers in the car, they should have more freedom to be able to give more of their attention to the content and the entertainment and not have to worry about driving the vehicle. The telematics area has been in place for quite some time, but has been fairly limited in terms of capabilities because the connection to the vehicle in the past has typically been a fairly narrow bandwidth and is limited in the capabilities of the kind of information that it can provide. But now that many new vehicles are starting to ship with a 4G wireless connection that's actually built into the car, and as well a range of companies that are providing OBD2 dongles that you can purchase and plug into the car, this is enabling the vehicle to have much broader bandwidth and a very high-quality connection to the internet, and that can be used to help improve the navigation experience by providing real-time traffic and weather and other types of content into the navigation system. It can be used to actually monitor the way in which the vehicle is being operated, and that can, if you're a good driver, you can utilize that type of capability to help lower your insurance premiums, because the insurance company actually has proof of the fact that you do adhere to the speed limit and you do actually come to a full stop at the intersection, etc. In the emergency services area, we're seeing a lot of interest in using the fact that, for example, an airbag has deployed and that the vehicle is going to need emergency services, but in the past, a separate call would need to be made by the driver or by someone that's a passenger in the vehicle in order to get the emergency services people to arrive. Now vehicles can actually detect the airbag as deployed, and the car itself can contact emergency services. And then there's a range of diagnostic capabilities as well. So in terms of just the overall operation of the vehicle, the fact that it's connected is adding a lot of capabilities. Then we have kind of the future, near-term future, I would say, is that the vehicles are going to be able to start to communicate with and among themselves to share information, so that a vehicle that is encountering a section of road that is perhaps congested or is the surface is slick and the traction is poor, that can be detected by sensors on the vehicle and shared with other vehicles that are following, so that you have an anticipation that there's a condition ahead of you, and that can allow you to adjust the way that you're driving the vehicle. As well, there can be parts of the road infrastructure, whether it be toll gates or other access mechanisms that your vehicle can communicate with on its own, and that can help to ease the traffic and improve the quality of flow of vehicles through that area. And then, a lot of attention these days has been placed on the autonomous operation of vehicles. Some of that attention is good. Some of that attention has been not so good. But there is clearly an evolution that's going on in the industry to enable self-driving vehicles to become a reality a little further down the road. And it's good that it's happening in phases, because what can be done with the technology today is to assist the driver and have a more enhanced sort of cruise control type of operation, where the vehicle can drive itself under limited control, but it's still really the driver's responsibility primarily to be driving the vehicle. And the connections can provide the additional data that can help the vehicle operation be guided but not completely controlled by a system in the car. And also to help detect, that vehicles have stopped ahead of you and that sort of thing, where the driver may be temporarily distracted. The vehicle can actually take over the braking or provide an alert to the driver to kind of jolt them back to paying attention. And then the longer-term view, of course, the vehicles will be able to drive themselves, but there's a lot of work that has to be done in the industry before that becomes a common place occurrence. So for us, we are creating solutions that we can interact with the car manufacturers to incorporate some of our technologies into their vehicle. They're realizing that historically their business has been around motor and engine technology, designing comfortable interiors, building a lot of hardware, and that they may not necessarily have all of the skill sets internally to be able to create a connected car on their own. And so it's very much a strategic alliance type of an approach that the car makers are taking. They're looking for partners that can bring the technology to them and help them to accelerate the way in which they evolve the design of their vehicles. And again, this is largely driven by the customer's expectations that what you can do today on your cell phone, you should be able to do that in your car. And that creates a whole different approach to the design and the testing that the car manufacturers have to do. Mobile operators are also very interested in the vehicle, because vehicles represent a large audience or a large customer base for them to have subscriptions to the carrier's services. And so that has really started with just providing the basic connectivity. But of course, mobile operators don't want to be just a dumb pipe. They want to be able to add value. And so you see a lot of initiatives happening in that space, for example, with Verizon acquiring companies like Hughes Telematics to basically bring the knowledge and the skill set of the telematics space and the connected vehicle space, bring that knowledge into the operator so that they can design services that are more complete and deliver those to the automotive companies. And then also the dashboard is starting to open up a little bit, and some of the auto manufacturers are actually enabling a kind of an application development environment to exist so that third parties can take their applications and adapt them for use in the vehicle. And again, this has to be done in such a way that it isn't a distraction to the driver, but at the same time provides a rich enough experience that it meets the expectations of the consumer. You know, and I think music applications like Pandora, as an example, are becoming very commonplace now in vehicles, and that's going to continue as we move forward. So this is some research that has been done just to kind of gauge what is the level of interest and where are the opportunities here, at least in the U.S. market, for people to do own or lease a vehicle. And you can see that the interest level is actually pretty high, but it's not, it's not extremely high. So there's very good opportunity, and it's something that we're investing in quite heavily. A lot of companies are investing in this space. And I think as more people start to have the enhanced experience that comes from being in a connected vehicle, that if this type of survey were done in another year or so, that we would expect that the interest levels would be even higher than the percentages that are shown here. Because many times people just don't understand how some of these things could work until they have the opportunity to experience them firsthand. So I think Josh was going to ask a question at this point in the process. I'll just pass back to Josh momentarily before I go on with my next slide.
Sure, yes, thanks. Brian, for doing that. Yes, so please go ahead and fill in your answer. Question is, what is the outsourcing model of your IoT testing practice? Obviously, connected car is one, but this also applies to other industries. So would it be no team is in place, or maybe you have your in-house team? Is it partially outsourced, or maybe all of it's outsourced because you're just short on staff? So please go ahead and answer that in the question. And looks like we have our results. Looks like currently no team is in place, and that is very interesting with most of the audience responding. So very interesting, and tells a story around IoT testing and your practice. So I'll go ahead and go to the next slide and pass it back to Brian.
Thank you, Josh. Yeah, at this point, what we'd like to do is to talk about a specific project that we've undertaken with Infostretch. And it was actually built, a solution that was built with Infostretch's support, utilizing a platform that Comtech developed and has been evolving over the past several years. And we call it Location Studio. People that are interested can actually go to the www.location.studio website and see more detailed information. But essentially, it's a platform offering software as a service, and it has three primary areas of functionality. The one that we call GeoSuite is really around enabling the display of maps, the calculation of routes, the delivery of turn-by-turn directions and guidance, and the incorporation of a lot of real-time content like traffic information, movies and events, gas prices, etc. And all of that type of content plays nicely into the connected car to enhance the experience of driving the vehicle and riding in the vehicle. And then we have a positioning suite, which is used to actually determine the position of things. And in the case of a vehicle, you generally think of vehicles being outdoors when you need to locate them, and so naturally things like GPS have been used for that purpose for a long time. But of course, vehicles do spend time moving indoors as well as in areas where the GPS signals are blocked or interfered with. And so there are some other ways of combining signals from sensors in the vehicle to help make up for the temporary loss of GPS and feed that information into the applications that are running in the car. And that's another area of functionality that Location Studio supports. And then the other element is messaging, because generally you need to, with mobile devices that are moving between locations, you may want to send an alert when a vehicle arrives at a certain place, or when it departs a certain place, or when it is a certain distance or time away from a destination. And so our platform provides a very broad range of messaging capabilities. And then these three areas of functionality within the Location Studio platform can then be utilized in developing an actual application. And so what we're trying to do with our platform is to work with key partners such as Infostretch to create essentially a reference design for an application in a particular market. And so for the connected car area, we've worked with them to enable our platform to be incorporated into a solution that has a pretty good range of functionality, but is ready to essentially be customized by an auto manufacturer or another partner to adapt to their specific requirements without having to redesign from the ground up, and is built on components that have been thoroughly tested and interoperate together very well. And so I think at this point, what would be good is I'll pass things back over to Sunil, and then he can talk about the way that Infostretch actually worked with our platform to create this connected car reference solution.
Thank you, Brian. So as Brian mentioned, Comtech has an excellent suite of services which kind of provide different aspects of location and adding enhancements to an entire IoT use case. What Infostretch helped them with was basically to kind of integrate those into an application and try to bring the three pieces together as an application that can really show a connected car use case. So we kind of built the integration points from the mobile app into these components through REST API integrations. And the important part, the very crucial part was to make sure that this particular application can really be branded for multiple clients. And so there were some architectural decisions made and designs done so that you could actually have a generic template that can really be co-branded depending on where this app was really installed in. And putting that together was an important aspect of working very closely with the Comtech team to make sure the backend service can support some of the required elements as far as integration went. And one of the important aspects also was to make sure that we were working with them while the backend services are also optimized to some extent, because these are very rich services with lots of capabilities, and we had to have the strategy in place so that we could not only leverage the latest capabilities that were added to the services as we were undergoing with the development, but also at the same time we could continue on our own stream without having any dependency issues. And of course, lastly, the need was to have a quick reference solution. So time was of essence, and Infostretch worked very closely with Comtech to make sure that the reference solutions they bring out are really quick and could be prototyped really fast. So a great example and a great showcase of iterative development and working with different constituents, geographically distributed, and also providing different aspects to the whole solution. And then some other important pieces of the solution essentially was to kind of make sure that the joint solution that we kind of can be put together, it was important to kind of provide a very sleek and modern interface as a solution, so that the different in-vehicle navigation components could be really expressed in a very intuitive fashion for a user to use. And so Infostretch really handled all the UI design, application design, along development, all the way up to integration and testing. And talking about testing, some of the challenges with testing such a solution obviously is to make sure that we can get location which really represents location of a moving car. And so, there were a couple of things we worked with Comtech on to make sure that we had reference solution and reference data on the back end which would mimic different kind of movements, and trying to work with these kind of test data. And we also built certain mock services and mock applications on our side to kind of replicate this test data. So data replication is an important aspect of these kinds of testing, and it really surfaced very well when we actually built this application with Comtech. Because you have to simulate different location scenarios, whether it's in a garage or whether you're out in the open, and each have their own nuances as far as the test data attributes really go. So the goal for us was basically to build this solution and kind of open up new opportunities for Comtech, yet allowing them the flexibility to modify it as needed for other solutions. And going forward, Infostretch is working with Comtech to kind of develop new services which will link connected cars with actually to connected families for tracking and safety. And in addition, also Infostretch is porting the Comtech solution onto different platforms, which could be used by other automotive OEMs and manufacturers, so as to expand the base that the Comtech backend services can be leveraged in terms of vehicles. And the key outcome of this development and testing solution, having worked essentially, was to make sure that the new integrated application really gave Comtech a better way to promote the connected cars with automotive OEMs and tier 1 suppliers, and that was the goal right from the beginning. And also the UI really stands out from the competition, and it's a configurable UI which can be co-branded, so that really gives a lot of advantage in how it can be in terms of scaling the application to multiple OEMs. And also the whole process of getting the quick prototype up and running, in just a matter of hours, rather, if we would say, and not weeks, helps to quickly test out the solution on a new OEM really quickly, and then tweak it in a very iterative fashion. So the development cycle that it takes to really, take from an identification of an OEM to actually having it tested is really short. And the reason being the right elements that were built as part of the development process and also the architecture to support this kind of a need in the future. So that kind of sums up the key really the key outcomes out of this engagement with Comtech. At this point, I would like to throw out a poll again to the audience. I think the poll is about having heard about IoT nuances, having heard about connected cars, having heard about the testing challenges and how to overcome it. I think the question is are you interested in talking to experts in Infostretch about IoT testing? And and of course if we get the results quickly. Yeah. Thank you. And I think with this, Josh, I would like to hand it over to you.
Thanks, Sunil, and thank you everyone for joining us today. You will receive an email in the next 24 hours with the slide presentation and link to the webcast replay. We also have a great promotion right now. Take advantage of a free, no-obligation assessment that Sunil might have mentioned around our IoT testing and with one of our IoT testing experts. If you do have questions, please contact us at info@infostretch.com or call us at 1-408-727-1100 to talk to your representative. I'll now pass it back to Beth to close out. Thank you.
All right, thanks very much, Josh. The speakers will now be taking your questions from the audience. We already have some here, but feel free to continue asking questions by typing them in the text box beneath the panels on your screen and clicking submit. All right, the first one I have here, this person wants to know, why should an enterprise work with a third party for IoT testing?
Sure, I'll take that. I think the IoT testing, if you look at the breadth and the depth of the testing that is needed, an important component of IoT testing is having the right infrastructure in place, and also building out the right harnesses to actually kind of optimize your testing. And that essentially takes time and effort, and also it needs a lot of right integrations in place. And it eventually ends up being a build versus buy situation, and because the complexities involved, it is often better to work with a third party who have these harnesses and infrastructure in place already, so you don't have to go through that ramp up before you start testing, before you start your IoT testing.
Okay, thanks very much for that answer, Sunil. Next question, what are the key elements of an IoT testing practice?
So for an IoT testing especially, I think one of the important aspects is going to be to make sure that there is coverage across the entire breadth, because IoT cannot only be a testing around sensors, or it cannot only be a testing around cloud. You need to have enough testing across the breadth, because all the systems really interact in a very dynamic fashion to really build out a final solution. So that is going to be one key element, to have the breadth of testing. And the other aspect of an IoT testing practice is that it needs to be modular in nature, so that there are certain aspects of the IoT testing, or certain layer testing, which could be done independently also. Because you could have everything else in place and everything is working fine, but you just need a very in-depth testing of a certain area. So although you have a breadth of testing, the testings have to be modular enough that they can also be run independently if required. And of course, the third part is having the right infrastructure in place, interconnected infrastructure, which can be scaled very easily. So I would say these three are the main tenets of an IoT testing practice.
Okay, those are all some great points. Thank you. How important is automation in IoT testing?
Automation is very key. As you saw in the earlier slides, the complexities of IoT testing are numerous, and there are a lot of different moving parts. So in order to have repeatability, in order to have scaling involved, any kind of testing that in IoT needs to be automated, because you need the ability to not only be able to programmatically tweak parameters in your testing, but also to have the right frameworks in place, so that you can really get real-time data in a meaningful way. And it is especially because of the dynamic nature of IoT that automation is very paramount. And I think you can do a bit of manual testing in IoT, but that is just at the initial level. But you really need to have deep automation testing to really make it successful.
Okay, thank you. And I'm going to ask that anybody interested take down Infostretch's email address or phone number right now, so that you can take advantage of the free no obligation assessment to talk to one of their IoT experts. And with that, I will say that's about all the time we have, so that will be the conclusion of this web seminar today. I'd like to thank our speakers, Sunil and Brian, for their time, and Infostretch for sponsoring this web seminar. And also a special thank you goes out to all of you in the audience, of course, for spending this hour with us. So have a great day, and we hope to see all of you at a future event.
Thank you, Beth.